Hello, and welcome to the Malvern Analytical Web Seminar Program. Today's title is Demo at Your Desk, Epsilon 4, Ready to Make Its Impact, presented by Dr. Lieven Kampenaars and Dr. Michel Sanchez. And now we're going to move on with our presentation with Lieven and Michel. Hello, gentlemen. How are you today?
Hello, Linda. Yes, I'm fine, thank you. Me too. Yes, okay. So, good morning, good afternoon, ladies and gentlemen. Thank you for joining us in this live demonstration at the desk. My name is Lieven Kampenaars, and I'm the Business Development Manager for the benchtops. I'm Michel Sanchez. I'm the Product Manager of our Epsilon benchtop range. And today we will present the star of the show, our Epsilon 4 recently launched on the market since this year. So, Epsilon 4 is a benchtop XRF spectrometer. And as you can see, and that's also the purpose of this demonstration, it fits on a table and it has a compact size. If we open the instrument, there you can see that the instrument has a sample changer, and that can accommodate 10 samples for batch measurements. And you can also take out the sample changer and load your samples individually, and those samples can be anything as long as it fits in one of those cups. For this purpose today of the demonstration, we pick out one sample, but as you can see, or maybe not, we have loaded a few samples like a metal or a plastic or a PVC. If you have a sample that does not fit in one of those cups, there's also the possibility to fit the sample directly in the instrument for measurement. So that's the loader. Then from the outside, we can see the settings of the instrument. And of course, that's also operated by a computer, which is separate, also with the Epsilon software. And the Epsilon 4 is, as I said, limited in size. Also on the back, the only thing we have installed here is normal electricity. And we also hooked it up to helium for a power boost, you could say, or intensity boost, specifically for the light elements. On the front, even if I open the instrument, you can see that the X-ray on lamps are still on. So that means that the instrument is still producing X-rays, but the system is safe for the operator, because everything is well protected. Even when I take out the sample changer, it's still safe and sound. The advantage of that is that the X-ray tube can stay on continuously, and that's also better for the lifetime of the X-ray tube, and also for the stability of the instrument and the results. And so I'll hand over the time to you, Michel, for a few slides on basics of the instrument and also on certain applications. That's all for. There are 3 configurations available. Each configuration will answer an application of requirement sets of the customer. Our general purpose 10-watt system with SU10 detector can be used for the analysis of from fluorine up to americium. If you need a bit more power and higher sensitivity, you also can go for the 15 watts combined with the SU30 detector. It's still able to analyze from fluorine up to americium, but due to the higher power and larger detector, you can measure or to lower detection limits, or you can measure faster. For the users who are interested to measure the lightest element from carbon to carbon, nitrogen, oxygen, and fluorine, it's also possible to choose the 50-watt system in combination with SED30 Ultra detector to have extended light element capabilities. Here on this on the image on the left, you see different samples are fitted in the sample changer of the Epsilon 4. We have a 10-position sample changer, as you can see more clearly now. And Lieven already demonstrated that this tray is removable. You see that all sample cups are equipped with hook wheels, which is used to spin the sample. Spinning the sample during measurements improves the accuracy for the not that homogeneous samples. So if your sample is heterogeneous, it helps to spin the sample to measure a larger surface area of your sample. And as you can see in the picture on the slide, you can measure solids, powders, fused beads. It can be used for to measure steel rings, for liquids in a plastic cup, or also for dedicated samples like small mass holders, where you can measure down to 100 milligram samples of air filters. If you get your sample, it's up to you to determine your strategy to analyze the samples. You can create a classical calibration with using certified reference materials, which leads to the highest accuracy. Or there's also another possibility. For some applications, it's hard to find enough certified reference materials to set up an application. Or you have so many different types of samples, it's not worthwhile to set up and maintain the different calibrations. For that, we have a standardless analysis solution on it, which is capable to measure a wide range of materials. The software one solution can be used to measure samples from solids up to pressed solids, or liquids, or loop powders, what you need to analyze. Which strategy you choose, in every case, it's a straightforward analysis procedure. You will load your sample, you select your method, enter your sample name, click on measure, and you determine the position in the capsule. You can load every 10 samples per batch. And after some minutes, or after a longer time, if you measure a complete batch, you have your results ready. We call it a live demonstration. For that, I will give the floor to Lieven to load one of our samples. I have here a sample of fused bead clay. So this is a fused bead of a cement sample. And let's analyze this with Omnium. That's the standardless method. And so we reduce the measurement time also for this demonstration. I think the measurement time, Michelle, was about 5 minutes. And then so in those 5 minutes, the Omnium, so the system together with the software, will scan the sample and will analyze all the elements that are in the sample and report those elements that are actually in the sample with element in concentrations in percent down to ppm levels. So Michelle, I put the sample in position number 1. That's good. Then we can start the measurement. I already opened the software, so let's switch to the software. Let's select our application. For now, we choose Omnium. So I open the Omnium program. I select the right sample type with parameters. I enter the sample name, cement in this case. I click on measure. I select the position in the carousel, and you click. If it's okay, now the cover of the system is closed and the measurement is running. Yeah, so that's the click. The click means that the lock is the lid of the instrument is locked. So that means that the operator or anybody else accidentally cannot open the lid and get exposed of X-ray. So that means the system is safe and sound in all cases. Okay, in the meantime, it will take 5 minutes to measure the sample. Let's switch to the presentation again to show the real power of the Epsilon 4. Because for many applications, there are test methods or norms for XRF to determine the elemental composition. For example, there are test methods or norms known for air filters analysis, for ultra-low sulfur fuel, or for cement, or for pharmaceutical standards, where you measure the impurities, and also for many more applications. We will show some of those examples, but for this we use a calibration. Is it hard to create your own calibration? We think it's straightforward, and our software will help you to set the settings. A calibration can be set up in a limited number of steps. First, you select the elements of interest. Then you set the conditions, like measurement type, power. This is something you don't have to figure out yourself completely alone. Our software helps you, the user, by proposing some settings. Then you load your sample, your standards, and you measure them. If your standards are measured, you can calculate your calibration lines. And from that, you have your basic application ready to measure your routine samples, your unknowns. For some applications, it needs some iteration. But for a standard application, it can be done in a limited number of steps. And if we set up the calibration, we can achieve non-compliant performance. For example, if we go to air filter analysis, there is an XRF norm used to measure air filters. It's made by the EPA, the Environmental Protection Agency. The number of the norm is the IO3.3. In the graph on the bottom of the slide, you see the requirements of the EPA methods. They require that an analysis instrument are able to measure a certain lower limit of detection for a wide range of elements, from sodium up to lead. Those limits are shown as the gray bars in the graph. We did set up the application with the Epsilon 4 in 45 minutes per sample. And as you can see, for all elements, we comply with the requirements set by the EPA method. On top of that, air filters, one time you have Teflon, the other time you have Mylar. You want to use one calibration for different filter types. For that, we have introduced a new feature in the software called length subtraction, which can be used to compensate for the used filter. Another application heavily regulated is the analysis of sulfur in automotive fuels. The latest regulation sets the maximum permitted sulfur concentration at 10 ppm, and there are several test methods available to determine the sulfur concentration in fuel. And two test methods of norms where EDXRF can be used are the EPA TFT regulation and the ISO 13032 test method. And in both, for both test methods, it's important that you can measure very repeatable of a 20-day period at least. In the graph, we show the repeatability for ISO 13032, and we measured a commercial fuel over a time span of 20 days. I see there's now something popping up. It means that the measurement is ready. We will later see the results, but let's first take this part of the measurement, of the presentation. As you can see that for over 20 days, the orange bars versus the gray line shows that we comply fully, and the TFT using a standard deviation after 20 days. That's the maximum standard deviation is 0.9 ppm, and after with the Epsilon 4, we accomplish a standard deviation of 0.5 ppm. If you go to cement, where the ASTM test method C114 is used for the analysis of the composition of cement, we can comply to the test method in 10 minutes. This test method exists out of two parts. You have to prove your reproducibility and you have to prove your accuracy. In both graphs, we showed the required, the allowed difference between R duplicates, R between the measured concentration and the certified values with the blue bars. And you see that the green bars shows the actual difference measured obtained with the Epsilon 4, and for all 11 compounds we comply in 10 minutes. And another new exciting application for commonly available for XRF is the analysis of elemental impurities in pharmaceutical products. For this application, we used only a limited sample amount of 100 milligrams. You see at the bottom of the slide how such sample preparation looks like. It's dedicated small mass holder where a limited amount of sample can be loaded into the spectrometer. We used a measurement time of 35 minutes, and we compared our results with the ICH pharmacopoeia to determine if we can comply with the requirements set for a 1 gram daily dose. To do this application, we used our own independent cellulose samples. We developed 3 different sets, all with their own elements, and in total they have 20 different elements in the cellulose matrix. On the right, those samples are supplied as loose powders, and determining on the part in the process where you want to measure, you can determine to use 100 milligram small mass holder, or you can use the 5 gram press pellet. We now stick to the 100 milligram small mass holder. We show the results on the right, and you can see with the Epsilon 4, we comply with the full ICH list for a 1 gram daily dose. We know that the measurement has been ready. Let's see if the system can be opened again.
Yeah, that should be possible, yes. So the sample has been measured, so the changer is back in its loading position, and the shell is
let's go over in this case, this is cement. So this is the important elements for compounds is, let's start with the silicon oxide in this standard. Which one? So I have here 26.34. And according to Omnium, we measured a concentration of 26.1%. So, okay. Then aluminum oxide, also another important element. On the certificate it says 8.95. And what does it say after the screening of the sample? About 9.1%. Okay. So iron oxide, another important element, 1.82%. 1.80. Okay. And calcium oxide, also of course a major compound in cement, 54.9 or 90%. 54.7. 0.7. Okay, yeah. 0.9 and 0.7. Okay, nice. Yes, of course. We have a lot more elements, so like magnesium. I have 3.33 in here on the certificate. 3.27. 7, so also very close. And then, then a few less important elements. The potassium, let's say. Which one? 0.44. Potassium oxide. 0.46. 6, nice. Then let's say the last element in this exercise for the screening of the cement sample is manganese oxide, is 0.18? 0.17. 17. Okay, those are really nice examples at screening the sample that was just 5 minutes without any figuring in the software and with a fuse beat as per that as it is 1/10. So those are, I would say, a very nice result. If you want to check if you miss an element or if the software missed the element, it's not that you have first the data to show you what's the data, but you always can do a double check by opening the measurement in the software, and then you can see that we use multiple conditions. So let's select one of the conditions and maybe like elements because it's maybe the most crowded sector. So we can see that the software fits nicely the different elements present, and it didn't skip one of the elements. I think ready with our system. So let's go back to the presentation to finish that part. We should demonstrate here an example with Omnium live. Next to Omnium, we have other analysis solutions available, like fingerprints, where you can set up your own positive material identification database to work in a regulated environment. For example, if you are working in a pharmaceutical company, we have enhanced data security, which is FDA 21 CFR Part 11 compliant. If you want to measure layers on multi-layer samples, we have status available, and if you want to measure different kinds of oils, we have a solution called OilCase. These are our dedicated software solutions. And next to that, we also offer advanced calibration solutions. For example, if you want to measure toxic elements in polymers, we have our own dedicated solution, ToxCell. We can help you with our pharmaceutical standards for setting up the pharmaceutical application. Or, for example, for mining, we have the solution WATCHI. What is WATCHI? It's a solution already available on our floor standing instruments for many years. An advantage of WATCHI is if you are users and you want to have to analyze a lot of different sample types. For example, you have to measure silicates, carbonates, phosphates, or unknown rocks, or you want to measure salts, iron ores. It's a lot of work to maintain all those separate calibrations. And also, not even talking about maintaining, also you have to gather a lot of certified reference materials. For this case, we developed our worksheet solution. What does it do? Our worksheet solution exists out of 19 synthetic wide range oxide standards. So 19 different standards which will be fused to a bead. These 19 standards covering 21 major and minor oxides, for example, iron oxide, phosphor oxide, etc. All samples are prepared and standards are prepared as fused beads to remove the mineralogical effects, which makes it possible to put them all at one calibration line. We measured 11 certified reference materials using this solution, and we were able to get a nice linear relation between the certified concentration of 11 different materials, like an iron ore, like a silicon oxide, like a bauxite sample, a linear relationship with the measured concentrations for all different compounds. So we demonstrated a little bit of performance of the Epsilon. We claim that we can now make a big step in performance. What is the secret of the performance of the Epsilon 4? The high performance of Epsilon 4 is a combination of 4 main parts. First, we have our own in-house developed X-ray tube. It's a 15-watt tube with excitation capabilities between 4 and 15 picovolts, and we can apply currents up to 3 milliamps. We have a large detector, the SEZ30, catching all the photons excited by the tube in the sample. And in the past, the electronic XRF instruments were sometimes the limiting factor, but with the latest generation of electronics, we are now able to handle incoming count rates up to 1.5 million counts per second at 50% dead time. Why do I add at 50% dead time? Until 50% dead time, you keep the linearity in your calibrations. So that is needed for the accurate calibration. And further, we developed our algorithms used to deconvolution spectra further to the latest generation in our Epsilon software, which is helped to deconvolute the incoming spectra to the exact concentrations of the different elements. And next to the 4 different parts, we designed the optical part such that we create a very close coupling. So the closer the coupling, the more photons will reach the detector, especially in the case when you are interested in elements like fluor, sodium, and magnesium. I think this is the end of our presentation. Next to offering instruments, we as Analytical are always able to help you setting up the instrument, thinking with you what the application should be, where you can get standards, and we offer for this a worldwide support. I think this is our end of the presentation of the content. I think it's now time to open the Q&A. So let's see if questions are coming in.
Okay, thank you, gentlemen. Excellent presentation and demonstration there.
I got here a question of Dennis Sosner. I hope I pronounced the name correctly. Our application is ambient air particulate filters. Which are the optimal configuration and accessories needed? Can you talk about this configuration? Nico, can I give this question to you?
Yes. For air filter analysis, I think you also mentioned in one of your slides some of the results. The configuration is exactly the same instrument as we demonstrated today. Then our suggestion would be, as a specific configuration for Epsilon 4, to use a silver X-ray tube. That gives a better performance, slightly better performance for the live element, and which is also shown in one of the slides. We also have the data sheet where we also tell a little bit on the details of the configuration, also the conditions that we use, the measurement times, and the results.
For air filters, we have something else. We have special set cups able to affect the higher surface area of the samples.
Yeah. So we have the cups, and we also have special inserts that you can place on top of the air filter so that the air filter stays in the same position during the measurement. Yeah, so all of that is a package that is available for air filter analysis.
Another question? Yes, I have multiple questions. A question from Salim. Hi, are the samples analyzed as loose powders or as pellets, I think?
Depends. Of course, you can use, you can analyze any sample type as a loose powder. Then you have a disposable cup where you take a spoon and put it, place it in the cup. That's the loose powder. One alternative is pressing the powder, and another alternative is fusing the powder. Why the difference, or what is the difference between the two, is the principle is the more sample preparation you do, the better your result will be. When you analyze as a loose powder, you will get good results. With pressed powders, your results will be better in accuracy. And of course, if you use fused beads, then you take away all the mineralogical effects from the powder, and then you have the best result. So it's a combination of time, sample preparation, and also the results, if they are good enough for you.
In a follow-up question, we mentioned it's for pharmaceutical grades.
Oh, no, it's not. So for pharmaceuticals, mainly for pharmaceuticals, the interest is in the heavy elements, let's say the toxic elements and the metals, where the difference between a loose powder and a pressed powder will be smaller. And so, yeah, loose powders can be good enough in accuracy. Pressing the powder, if you have more material, that will be slightly better, yes. But in the case, specifically for the pharmaceutical industry, when you have the APIs, active pharmaceutical ingredients, and when you only have a few milligrams, then it's hard to press, so then you can use that or analyze it as a loose powder in a special cup that we have for small amounts of material.
Okay, I got a question from Jason. What are the sample changer options? We analyze sample continuously 24 hours a day. Are there options for automatic loading or more than 10 samples?
The sample changer is a standard 10 position. We also have a solution for automatic loading. We also have commercial material for that to show how it looks like, where you can continuously load samples into the Epsilon 4. So the Epsilon 4 doesn't have to be modified. It's, let's say, an option, a bigger sample changer that can be customized depending on the number of samples that you want to load. Can be 10, can be 100, can be 1,000 samples if needed. That can be customized made.
And he also asked what is the X-ray illumination area on the center?
X-ray
Illumination area on the center.
I don't understand the illumination.
The X-ray illuminates the sample area for about 10 by 13 millimeters.
Okay, okay, yes, the area.
The spot on the center.
That's about 1 centimeter in 1 centimeter by 1.5 centimeters for this instrument.
Can you tell to Tower a bit more details about petroleum product software or calibration techniques?
Okay, this can be a very long live demonstration now. But so as Michel pointed out in one of the slides, that one of the solutions that we have on top of the system, Epsilon 4, is for petrochemical users, is oil trace. And that is a software package combined with some basic oil standards and petrochemicals to calibrate the instrument that it becomes robust for different types of fuels, but also lube oils, to analyze the additives and also the wear metals in those lubricating oils. And those can be used lubricating oils and also new lubricating oils. And that's oil trace package. And we also have commercial material where you can look into the details. It's also available to be downloaded via our website, analytical.com.
Yes, I think that is the last question I received till now. There's someone else in the I have more questions. Via another way. How are you doing this?
Yeah, in any case,
Linda, did you receive some questions?
I have sent my questions on over to you. Thank you to the audience for those questions. It really enhances our presentation. And we will prepare to close our web seminar today. Thank you, gentlemen, for your work in showing us the Epsilon 4 benchtop. Please know that we have many stories on materialstalks.com, our blog site, regarding our benchtop instrumentation. And now back to you, gentlemen, for close.
Yes, Michel, I don't know about you, but I really enjoyed this short and brief demonstration, a live demonstration from the Netherlands. Well, thank you very much for your interest.
Yes. Thank you.
Yes. Anything else?
No, if you have follow-up questions or questions come to mind, please look for contact via our website or via maybe our sales agents in your region. Please contact them and let them. They will forward the questions to us, and we can answer them.
Yeah. So thank you very much for your attention and your interest.
Yes, thank you very much.
Thank you. Good day to all. Goodbye.